So if anyone is interested, you can just contact Kushal. He's standing right in the middle of them with the camera. Anyone interested in computer training, which will cover every component of CDH platform, right from high-tech school to Zuzu to signal marketing, the planning to start with Solr and Spark as well. Because it's not fully enterprise ready, we have training on us now. Once we have to handle on it, we will include in our training package as well. Okay? Anyone who is interested can get in touch with us and we can take it ahead from there. Alright, so let's begin with Spark. So Rahul and Shitosh will take up Spark. They are not workers, so we work in networks basically, and hence we are able to organize this event. So thanks to them.
Hello. Hello guys. My name is Rahul. I work at ThoughtWorks. I have been here for the last 2.5 years.
Hello. Yeah. Hi Ashutosh. I've recently joined ThoughtWorks. Been here only for 3 months. So I'm quite new to all of this. We're going to talk about Apache Spark today. I'll just do a brief one-liner before I hand it over to Rahul. Spark is basically a in-memory cluster computing platform which comes out of the database lab at UC Berkeley. It goes under the name of Math Lab. So we're going to talk about it today, how it sort of interleaves with your existing Hadoop infrastructure. Just a sort of caution, we may skip over certain big data terms like Hive and Hadoop and all that. If we do get time, we'll go deeper into it, but sort of assume that you know a little bit. If not, just raise your hands and try and answer as many questions as we can. Okay? Thank you.
So before starting the session, I would like to know how many of you guys have actually worked with, let's say, Hadoop or done some MapReduce things. Okay. Okay, good. How many of you use like Hive or some related thing like cascading or scalding? Okay, good, good. Very good to see. One more question. How many of you actually have used Scala or no Scala? Okay, a few people. So, okay, that's good. Apache Spark, right? There is a lot of traction going on in big data space right now. Recently, there's a benchmark called as Apache Solr, and the previous record holder was Apache Hadoop, which basically was kind of the benchmark solution for big data things. But recently, Spark broke that record, and that's how Spark got a lot of attention. You can visit the official site to know the details, and the difference between the speed up and all those configurations which Spark used to break the record was quite good. So you can have a look at those numbers. Okay. So let's start with the presentation. We all know what big data is, right? Big data is like lots of data. But there are few properties of data also which are kind of implicitly assumed by people. For example, big data is always immutable. What I mean by immutable data is you don't want updates. For example, there's a log statement, right? Your application log. That log is just a permanent record. You don't want to update any attribute of that, right? That's how the data is used. And also, the data might be semi-structured or unstructured also. And in few cases, it is structured, so it doesn't matter. Also, you don't want finite write operations on those data. A database is more suitable for those kind of operations, and you don't usually need such operations on such a huge scale of data. What you want is coarse read operations mostly. Okay, and due to the enormous size, you want horizontal scaling. You just cannot add let's say machine with let's say 128 GB of RAM. It won't scale basically. With both cost effectiveness and also hardware issues also, right? So few things, commodity hardware is the way. Hadoop itself established that quite clearly. It makes sense, right? Because you want to scale horizontally, because the data is continuously growing. The computations that you want to perform on those data are also, as you are seeing the power, you want to do more and more computations, and maybe with low latency, right? But there is a small problem. Since data is distributed across the cluster, the programming model becomes quite complicated. Now, you can't just assume there's a, let's say, what you would have done to sort a list of, let's say, 10 elements, you can't just sort a 10 terabyte of data, right? Because it won't fit in memory. So you have to have certain changes in your programming model. Before again jumping to Spark and in detail, small brush up. What is HDFS? It's the distributed storage that comes up with Hadoop. It is kind of well proven, well used. The cluster management job is done by Yarn. It is yet another resource negotiator. By introduction of Yarn, HDFS is decoupled with MapReduce computations. Now, MapReduce is just yet another application that runs on top of that uses HDFS storage. And all the cluster management, workload management job is done by Yarn. So you can run multiple kinds of jobs which rely on HDFS as underlying storage. Yeah, there are a few properties like fault tolerance, which is achieved by replication. You replicate data across multiple machines, and that's how even if a node goes down, you can just continue by using the replication. There is a concept of mapper and reducer. Is everyone familiar with what is a mapper, what is a reducer? Okay, cool. This is the basic diagram. As you can see, there is a name node. This is basically how ADFS looks like for those of you might know or might be with the data is split into multiple blocks, and blocks are replicated across nodes. And you are basically abstracted from all this. You don't have to worry about where your block is located, how many replicas are there. But that's how it is stored or handled in actual ADFS. Name node is node where are the blocks located for particular data, for particular file. And you can just ask name node, let's say I want to read this particular file, and it will take care of reading all the data blocks, give you all the data blocks, perform the whatever computation you want to do on that. Also, fault tolerance is achieved so that even if, let's say, a node in rack 1 goes down, the corresponding node where those blocks reside, you will get a handle to that. And you don't care about that. You don't even have to realize that, okay, a machine went down. Little brush upon how MapReduce works. As you can see, by the way, if anyone has any question, you can ask right away. No worries. So this is a very simple example of what MapReduce is. This diagram is not mine. So there is this input at the leftmost part, which is basically splits. Let's say you have 10 terabyte of file or whatever data set you have, right? It is spread out in lots of nodes in the cluster, underlying cluster. And you want to perform some computation. For example, the hello of big data. You want to do a word count, right? So how will you do that in the traditional MapReduce world? So you write mapper. What is a mapper? Mapper is basically maps your input to some form that you want. Let's say in case of word count, what we want is map each word to constant 1, right? So that's what the mapper does. It reads a block and applies the computation, and this is done in parallel. So each block will have its corresponding mapper, and it will be done in parallel. That's how you get a speed, right? And yeah, this is very important. There is a shuffle phase also involved. What it does is mapper emits a key value pair, right? It is the framework's job to actually shuffle and sort the key value pairs so that each reducer will get the data for just one key. For example, you have hello world and world hello as your input, right? The mapper's job is to emit keys as like hello comma 1, world comma 1. And I'm kind of assuming that you know how word count is done. So, right. And the shuffle and sort phase actually does the whole network I/O. Actually shuffles the data between blocks so that a single reducer will get all the keys grouped, right? This is a quite costly operation. I would have to again repeat. Since it involves both disk I/O, because the intermediate output is persisted onto a persistent store, mostly ADFS, to achieve the fault tolerance, And it also involves network IO. Because since the keys might be spread out in multiple partitions, you need to basically group those. So that involves network IO also. And then there comes the reducer phase, where the reducer will get the key value pairs, values for all grouped by keys basically. And then you can use reducer logic, whatever you want to do with the values for that particular key. In case of word count, you just want to sum up all the occurrences, right? And you store back after the logic is applied. You just store back to the persistent store again. That's how a typical MapReduce works. So it took me so long to even understand how to write a non-trivial MapReduce job. When I was exploring, everyone just talks about, let's say, word count example. But I don't want to do a word count example in real life, right? If I want to do some non-trivial job, there are so many pain points involved. First of all, I have to just think in terms of map and reduce phrases. I might even don't know what a map and reduce is unless I have done, let's say, some functional language or I have worked in Ruby to even know those functions, right? Again, the map reduce or the Hadoop itself was meant as batch job processing framework. So it is inherently done in batch mode. So latency is not that bad, that good. It's very much a high latency job, I would say. And again, forget about testing. There are few frameworks or kind of libraries available for doing testing, and people kind of ignore this fact. Because what happens is let's say you are working in a real world cluster, right? You might as well work in production cluster rather than working on, let's say, some testing cluster. Why? Because there's so much data, you can't just replicate the production cluster back to, let's say, a testing cluster, and that's how it is. So how do you guarantee that your job is actually, your MapReduce is actually doing the work you wanted, right? So it is kind of not dual. You will manually take a sample of data and you will run the MapReduce on that particular sample and maybe by hand check that. Or maybe if you are lucky enough, you find some library like MR unit and all. Or maybe you will write a user wrapper, which is a cascading, scanning, lots of them are available. And you will do testing or maybe skip that itself. Basically not trivial for test. Also complex workflows. Real life job will consist of multiple phases which you have to think of. Let's say I want to index all my documents. Like what I will do is like a word and sentence. Now I know how will I do in, let's say, in memory, how will I do in, let's say, a list of statements, list of strings, right? But in MapReduce phase, believe me, it is very not trivial unless you visit some law or read some already implemented solutions, right? So not trivial. And also it is not at all meant for iterative processing. I won't go into in details for that. But yeah, these are kind of pain points I would say with MapReduce. I will come back to this slide later. Yeah, there are few wrappers available. For example, there is this cascading thing, which kind of wraps you some of the underlying MapReduce. You don't get MapReduce, but you get collection like interface. But again, these are just wrappers. You don't get any performance benefits. Same with scaling, it's the Scala wrapper cascading. There is a high use from Facebook, which exposes SQL-like interface over the underlying distributed HTTP storage. And yeah, it's quite evolved. I would say you can do joins, yes.
How is it this cascading split from high? Is it the same with cascading?
No. So cascading is a Java library. So you use Java API, which allows you, for example, in MapReduce you deal with input splits. You have MapReducer. In this, you don't actually deal with input splits. You get higher level abstractions. I don't really remember those abstractions, but it has something to do with sync and all. It has its own terminology. Basically, you can do dot map on a particular collection. You don't have to get a map or add a reducer for that. It is quite evolved library, I would say. It also allows some support for testing.
And what about scaling?
Yeah, scaling is just about cascading. Cascading is a Java API, so you will have to do that awkward anonymous function way to do the collection operations. You might have used Apache Solr library, and you might know what a map looks like. So scaling is just Scala cascading. The code becomes much more less boilerplate. Basically, these just get rid of boilerplate and provide some higher level abstractions. Right. Yeah, just one more point. In the beginning, I mentioned big data is inherently immutable. You don't don't want fine-grained updates, right? When it comes to MapReduce, MapReduce kind of ignores or does not exploit this fact for its advantage, for gaining the performance. What I mean by that is, I mentioned that intermediate results are persisted to disk. That involves disk IO plus network IO in the shuffle phase, right? So MapReduce kind of assume even LDF is a append-only store. You can just write and read multiple times, but you cannot just update a record, update a loop. You just can't do that, right? So still it is immutable in LDFS, but you can't exploit that fact for your advantage, for gaining performance. Right. Yeah. So we talked about few points like programming model is quite not user programmer friendly. We would like if applications could be more responsive and it would. I have seen few. I have myself written MapReduce jobs or heavy queries which took at least half a day or a day to complete basically, and then I will see okay what happened to the result and all. So it might not it's not what I want always, right? So maybe if the jobs are more responsive. Yeah, also, since Apache MapReduce was introduced, Hadoop itself was introduced, a lot of people felt this pain point and there are a lot of solutions. But those are totally distributed. For example, you want a SQL interface on the underlying data, you will have high. Okay, but how am I supposed to interpret? I have some output from, let's say, MapReduce jobs, but now I want to have some SQL-like interface. Okay, you save to a persistent store, you use Uzi kind of workflow manager to basically ask it to, when this job is completed, you will find this set of high queries, right? And this will continue. In a real world, you will have complex set of workflows, and this will be a pain. This is usually a pain. So this is kind of an anti-web pattern, I would say, and people do that. What can we do? Yeah, we also want fault tolerance. We don't want to give up let's say, fault tolerance, for example, for user programmer friendly programming model, all those kind of. We want those properties which HDFS gives us, right? It is totally fault tolerant. It is well proven. Yeah, code should be testable. I would really like if the code is doing what I wanted, right? And yeah, of course, open source, free. Okay, I guess. Till now, I kind of mentioned how MapReduce is and what are the pain points with it. And yeah, there are multiple solutions out there. People have tried to solve different aspects in different ways. There is one very significant effort that is going on from Angular Berkeley, Apache Solr. So these people were actually contributing to Hadoop when Hadoop was evolving and all those things. But they then spun off their own project. This is Zahania, sorry if I pronounced it wrongly, who actually, this project was his PhD thesis, and few ideas that he felt like functional ideas like immutable underlying data and collection like operations from the distributed data. He kind of implemented those in Spark, and this project actually got up. Whenever you will hear Spark, right, the only thing you will hear is it is in-memory processing. But I would say it is totally wrong. Spark is not at all just in-memory processing. It's totally optional for you. And yeah, as I mentioned, the recent benchmark that Spark set, or the petabyte sort record Spark has set, so it is totally performant. I don't have statistics here because you can easily find it. It's just a Google search away. And yeah, let's explore Spark. Any questions still here? Till now? No? Okay. Yeah, so what is Apache Spark? So Apache Spark is a cluster computing engine. What does that mean actually? I have heard MapReduce, I have heard LDFS, Hadoop is basically storage plus some distributed computation on top of that. What does a cluster computing engine mean? So the basic idea of Spark is they don't offer any distributed persistent storage for you. It's totally pluggable with Spark. You can make Spark work with HDFS storage also. It can work with JDBC connections also, some database that you already have. It can also work with use local file storage also. But in that case, you have to deal with the fault tolerance and all those things. It can work with Cassandra. You can just use the computation part in Spark, but the storage is done by Cassandra. And there are a lot of options available. So basically, you are not at all tied with HDFS underlying storage. plus. This was the first part. Second part is cluster management. Since we know this is distributed computing and all this, we want some kind of workload management. What should happen to job scheduling, right? I want this job to be done with higher priority and this job, and whatever the non-multi-level management, workload management things, right? So it again abstracts over that. You can just plug it in. If you are using HDFS, you can use it as YARN for application management purposes. Since the good point about YARN is it can run multiple applications, not just MapReduce. So Spark just becomes one more yet another application for it, and it can do the scheduling, right? There's no big deal. You can also have Apache Measures as the cluster management for Spark using Spark. And it also is standalone Spark miner, so the strict down minimum cluster management aspects with itself, so that you don't develop. For example, there is one more thing I would say. With Spark, data exploration is quite easy. I have my demo. I can show that. So let's say you want to just quick and readily see some distribution in the data, underlying data, like some size or some whatever matter, but you just want to set up a cluster for that and all those things, right? You might not need that. So Spark itself provides a standalone mode for those kind of purposes where you can just start a master and slave. It is totally easy. I will show that how to do that, and it will work. And you can just stop the cluster when you are done. They also provide EC2 scripts, so that it's again much more simpler. I haven't used that though. Yeah. Spark also provides interfaces in multiple languages: Scala, Python, Java also. Spark itself is written in Scala programming language, so if you want to explore, let's say, some code base in Scala of Spark, you might need to learn Scala. Yeah. So these are the components of Spark. Spark, when I say Spark, right? So these all components is what Apache Spark represents. Apart from the core computing engine, it also has some SQL-like interface. What was there in Hive? It is glowing. Right now it's a subset of Hive queries. Hive, and it's supporting more and more. Right now it supports, I guess, still the version 0.12 of Hive, but it's glowing, I would say. And yeah, it is totally interoperable. Let's say I'll be going to detail and I will do a demo. There is streaming aspect of the Spark streaming, where you can just compute on some streaming data, let's say a Twitter stream. That's a typical example everyone uses for showing the streaming demo. And you just don't have to worry or care about the fact that it is a streaming data. You can still do collection-like operations on top of that. There is machine learning language provided with as MLib, some graph processing also using graphics. I would have to say these are not at all different components. Sorry, some question. Okay, these are not at all different components. These are built on top of existing abstractions that Spark itself provides. The abstraction of RDD. What is RDD? RDD is a resilient distributed data sets. So these people actually use that existing abstraction to build these kind of libraries or the components to do graph processing or streaming or even machine learning. And this works, believe me. Yeah. So where does it fit in ecosystem? I said it abstracts the storage fact and cluster management fact, right? So how does it look when I, let's say, working with, let's say, HDFS as storage? And how do I use Spark? So as you can see, I don't have a pointer. There at the top though, from the right, the third entry is Spark. Again, they have mentioned in-memory Spark. It's totally wrong, I would say. But you get the picture. Like you have underlying storage in HDFS. You have cluster management aspects done by YARN itself. And now Spark is just another application that is using YARN and with HDFS as the storage, right? You can also see the cousins like MapReduce, HBase, and all those things, right? So Spark fits there on top of YARN. It uses HDFS when it comes to Hadoop, existing Hadoop ecosystem. But this is not just limited to HDFS, I would say. You can make this work with Cassandra, for example, and lot others. Local storage, JDBC connections, and others. Okay, why should you care about Spark? As I say, easy programming model. That's a very major point, I would say. That also enables you to easily test your code. It is lot more performant than existing solutions, I would say. Again, I don't have numbers here. You can use just those are just Google search away. And yeah, we'll see these when we will look at demo. It also offers in-memory caching. Yes, I would have to highlight that it offers in-memory computation. What I mean by that is, let's say you have a collection of data, and now you want to do some iterations of processing on top of that data, right? And you can just cache that data in memory so that the computations are much more faster. That way, you don't have to read every time from the persistent store, load it into memory, apply some computations, and all those things, right? It is cached in memory itself. This is totally optional. You can totally work in non-in-memory mode also. This is just for performance gain. This part also which I would like to highlight, data exploration. Spark comes with a Spark shell itself, so that which enables us to explore the data without even actually going and, let's say, modeling a map or that which we have to do in, let's say, Spark. What this means is, let's say I have some unknown data. I don't know what that data is representing. Right? It might be some string data, some string from Twitter, and or whatnot. Right? So I can just quickly open up a Spark shell and just explore data, see what contains, what is it contains. Maybe is it schema, with schema data or and whatever. Right? We'll see that in demo. Yeah. So this is a small example. So if you just ignore the first line and last line. So this part is the word count logic itself. This is written in Scala. So what I am doing is I just read the file which is on this. It can be on, let's say, LTFS or in local mode also, my local machine also, right? And I just split it the lines by a space so that I get words. I then map each word to a tuple with word itself and a constant one, and I just reduce it so that I want to group each group by key and add the counts, right? It will give me a word count. Right?
How many of you have seen, if I'm audible, how many of you have seen a word count example in MapReduce, right?
So here is what it looks like.
Yeah. So that's a problem, right? At the end of the day, I don't want to spend my time writing 150 lines of boilerplate code when all I could be doing is writing 3 lines of Scala, right? So that's the sales pitch. That's one of the sales pitch that Spark has, right? The programming model is so rich that you are able to use the collection operations, the rich Scala library or collection that it already has to reduce your work. Even if you, I think there was a similar example on Apache Solr as well, which ran into twice an MR size, right? And that promises you interactive computing, right? So this is the sales pitch, right? At the end of the day, I'm going to write my big data jobs and get on with my life, right? I don't want to spend my time doing this. That's not productive, right? So yeah, so are at least a few people convinced that it's actually worth investing time in, right? Cool.
And this is not all the MapReduce. There is one Django program where you have to set mapper class, then a reducer class, and a lot of others.
And you still have import statements which will span the screen, right? And that's how big the code is.
Right. So you get the idea, right? So I have a small demo where I will just show you how word count works. Just give me a minute.
I'll probably walk you through the demo while routing that. Sorry, can you hear me?
Yes.
So was there a question?
No? Okay.
Okay, when Rahul sets everything up, so basically where do you get Spark from, right? So where do we install everything from, how do we get started with all of this? So what you can do is you can go to the Spark site. It usually comes with a variety of distributions. There is one distribution for Cloudera, CDH5, CDH4, or MR2. You can probably take the standalone distribution, bring it down. It's on the screen. That's how you get it. What you will sort of eventually do is, if you want to add, say, yarn support for it once you download it, you can recompile it with certain flags, right? And then have the yarn support with it, right? So when you recompile it, it will require you to do some SPT stuff. SPT Scala's build tool. So you need to repackage the binaries again so that all of the support that you bring in for yarn or some other flags that you switch on, they become available. Okay?
So for getting started, right, you can just download any of the pre-built version. Just download it, and you are ready to go. For example, I downloaded for 2.3 version, and that's it. I just need to have Java on my machine JVM set, and it will work.
Just a small note on Java and Scala version that is 210 210 Scala version is 210 and Java 7. They don't officially support Java 8, but we have worked with Java 8 and it usually works, so should be a problem.
Okay. So I'll just open up a new Spark shell.
You'll find the Spark shell in the build folder.
Right. So what I'm doing here is just
Okay. Yes, question.
I have a question. Suppose I don't know Scala, so can I use Java because I'm Python?
Yes. Let me answer that. There are bindings available for both Java and Python. So there's a PySpark and there's a Java Spark. So you don't need to necessarily work with Scala all the time. The product itself is written in Scala. If you use Scala, your life will be easier. But if you do want to use Python or Java, feel free. Both are fully supported distributions. Okay.
I guess Python Spark is also.
yeah.
Yes. And I just want to leave that part towards the end because there's a lot of stuff to talk about there as well.
So I'll just open up a new Spark shell. Spark shell is where I will do the data exploration part. What I'm doing here is just specifying master, as in where is the Spark cluster that I have to connect to. I have already opened up or spawned a small Spark cluster. The way I did that was just going to SBin and just started a master and a slave.
So, just so I expand on this a little bit, there are two folders in SBin. SBin has basically all your shell scripts or batch files where you can specify your master configuration and your slave configuration, how many nodes do you want as slaves and stuff, which ports do you want to run on. By default, everything just works, so you don't have to do anything, but if you actually move to production, you will end up modifying this. And bin is where your PyShell or Spark shell, which is Scala and Python, and all of that stuff resides, right?
Okay, so after starting the cluster, you will see something. There is a web UI available for you. This is the master web UI, where you can see there is one worker registered. Since just I started one slave, I can see there is just one slave here, and it is very easy. You just have to first start the master, open up this web UI, and get the master URL here, and start a slave by specifying the master address here. And you are all set, yes?
Yes.
So, internally it uses SSH to
Yes.
create the nodes.
Yes. So basically, if you are going to run on a standalone mode, you're going to need passwordless SSH access from master to slave.
Right.
That should be easy to configure on any Linux or Mac machine, right? So, but on the when you move to production, I am assuming people are going to run it using CDH or something like that. So it's going to do the heavy lifting for you. You won't need to invest, so don't think about it too much. But if you want to run a standalone sort of cluster on your local machine, you need to configure SSH, passwordless SSH on your local host. Okay?
Just to add to that, you have Kerberos. Each software, each component here has its own functionality. Those functionalities principles are created. Principles we have but because all of this. If someone wants to communicate with someone, it has to go through that functionality. Spark is communicating to other Spark. It has to go through that functionality.
How do you configure a memory allocation? If I have a 2 data nodes with 12 GB RAM, but I want to give, I want to put some limitations on it.
Okay. So basically, when you go to the SQL folder, you have the ability to configure memory for your slaves and stuff, right? So how many CPU cores you want to allow it. So all of that you can do by hand. So the ability is there. By default, I think it starts to pick everything. For example, I have an 8-core machine. If I spin up 8 workers, then it will try and use all 8 cores.
So you can also specify the executor memory. There are standard flags available. So executor memory is the worker memory, where you can just specify let's say 2 GB if you want 2 GB each worker, and it will work.
So this is sort of primarily important if you are running a standalone cluster node, right? On your own machine, if you are experimenting developing, then you do want to limit memory, otherwise your own machine might go for a task.
So as we can see, I just opened the Spark shell from the command that we saw. Just specified the master, and now it is ready to basically use. Just one variable that has been provided to us, which is known as Spark context. It is the way you tell the Spark shell that what is the configuration of the cluster you have to connect to, for example, the master and all. SC is the way I can access it. I can ask for the master so that to verify if it has connected to the correct cluster.
Okay, so this shell is basically a wrapper around the Scala shell. Okay, so this uses Scala shell internally to provide you all of this facility, i.e. The Spark context, which essentially is a Scala thing, right? It's a Scala code, right? So it becomes available to you for iterative processing on your command line. Okay, does that make sense? So there's no magic, it doesn't come out of thin air. So there's logic behind that.
Okay. So we will be doing a small word count thing itself. A small input I have taken the readme file itself. It doesn't matter if you have set up a proper cluster. It can be a terabyte file also. It doesn't matter. I have taken a small file just for the demo purpose.
Yeah. So this is basically.
Okay. So what I am doing is asking Spark to basically load this particular file. The way I am doing is there is a text file method which just takes the path and I can just I'm done.
Can we go tab completion on this page?
Yeah, sure.
So basically what you have done is you have told Spark that you go read this file from my local file system. So similarly, if you had a Hadoop file system, you write HDFS blah 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 name node and all that stuff, right? So it would pick it up by default. So what Rahul has just done is show you whatever methods are available on the Spark context, right? That's a S3 period and then a tab completion. So all of these methods are available on your Spark context. Okay. So these are standard things that you would expect a driver program to have, right? Or something that's going to start my job, have all the configuration built in. So that's what this is.
So after we started a Spark shell, and if you go to the master UI, you can see right. So I can see that there is an application running. How do I get here? Yeah. Okay, we will see that later. So I read the file. If I see what is input right now, it is just a RDD of string. What is an RDD? RDD is a basic building block which represents the underlying data. It is made. It contains set of partitions in it, which can be thought of as splits in HDFS. But you are accepted from it. You just have to deal with RDD itself. And and it is quite rich in the set of operations it gives us. For example, you can just do a map. You can just reduce.
So this is where the power of having Scala at your disposal really shines, right? Because at the end of the day, you have a type to work with, right? An RDD of string. Now, if you have rich operations available on that type, you can work sort of in a very iterative linear programming model. You don't have to think in terms of a mapper abstraction or a reducer abstraction. You can clearly think of in terms of like I have a sequence of something. Now let me just have operations on this, like a group by, a join, a filtering. All of that becomes very simple to write and very simple to sort of understand as a mental model.
For example, I just want to see that how many lines are there in this particular file, right? So I will just do input.count. My bad. Yeah. And yes.
So, should we explain
Yeah.
Okay, cool. This is where the sort of the crux of what Spark does starts, right? So Spark supports basically two kinds of operations. One is basically an action, and the other is
Transformation.
transformation. Yes, good names those. So a transformation is basically an operation which takes an input from an RDD of T, right? Any RDD, and then transforms it into an RDD of U. So you are still in your RDD world. You have not left your RDD world, right? So think of it as in terms of Spark, it doesn't actually compute anything as long as it remains in the RDD world, right? It's lazy by default, so it won't compute anything, right? So you can then chain your operations and you will get on with it. Now actions is where the real action happens per se, right? Action is a terminal operations. So count that you saw is an actual terminal sort of operation where real computation happens. So when you say count, if I had, for example, let me elaborate this a bit. For example, I had a list of say 1500 elements, right? So I said list dot filter odd numbers, right? And then I said list dot filter, then continue with it and say numbers divisible by 5, right? So what Spark will do is not actually compute anything till I just say this. It won't actually go ahead and do anything for you, right? So but when I say count, then it will start to actually process everything. So how does it actually figure out what do I need to process and what happens under the hood, right? So under the hood what will happen is Spark will basically create a tag, a directed acyclic graph, and say, oh, this is my input. Now this operation was applied, next this operation was applied, so on and so forth, right? Till it reaches a terminal operation. So when it encounters a terminal operation, it will actually go and calculate the whole tag for it. So now the good part is you can have a tag which is as big as this, and then branch off in between and go and do something else, right? So I can have list.filter for odd, then 5, then 3, and then branch out and say 7 this side and 9 this side, right? Right? Does that make sense? That you can actually compose a lot of operations reuse. So to you it will look like you are actually working, say, with a linear sequence of this, right? It doesn't matter if it's distributed on HDFS. Does that make the sort of thinking model a little easier? Any questions so far? Or is it too heavy?
I didn't understand.
Sorry, yes.
I didn't understand what you said. Maybe it was too heavy.
Okay, let me rephrase this. For example, you have a list of 100 elements, right? So if I say list.filter odd elements. So what do I have now? Odd elements that remain in my result, right? Then I say for the filter by those which are divisible by 5, right? So what do I have left? Things that are divisible by, things that are odd and divisible by 5, right? So now I have a node in my DAG, right, which isn't yet calculated by Spark. In the DAG, directed acyclic graph, that Spark actually computes. The term for it is, I think, data lineage. Basically, Spark understands what operations you have run so far, and then at the end, when you actually specify terminal operation like count or write to a file system or so on and so forth, then it will actually go walk your graph and do the computation for you. Right? So if you do a lot of computation but if you don't have a terminal operation, it won't do anything for you. Right? Does that make sense?
So I guess we can show from the code itself what we are trying to say. For example, let's say I have a collection of 100 numbers, and so this can be either collection of, let's say, your number, or this can be some input source. For simplicity, I have taken a collection of 100 numbers. What it gave me is RDD of 8. We know what RDD is. RDD is kind of, let's say, a distributed collection, we can say, right? Now what can I do with this? For example, what I want is all the numbers which are, let's say, between 20 to 40, right? what I will do is I will do a filter such that each number is greater than 20 and number is less than 40. Right? As you can see, it did not give me numbers between 20 and 40. What it gave me back was again an RDD of int, which is some different RDD, a filtered RDD. What that means is now Spark has somehow noted down or he kept track that I have to apply a filter operation like this on this input RDD, the collection of 100 numbers. It did not actually evaluate anything. So what this means is this is a transformation. It did not actually result in some actual computation. It just noted down that okay, there is some filtering operation that I have to apply. Now next, let's say I will take this into, let's say, another RDD. Let's say well RDD 1 and now I got RDD1 as a filtered RDD, right? Now what I want is, let's say I want to square each number, right? What I will do is, let's say my RDD2 is RDD1.map, and what I will do, let's say each number I will square it. Okay. Again, it did not give me the squared numbers. It just noted down that okay, I have to now if you see what it's returned me an RDD of int, and which is a mapped RDD. What it means is now it has noted that okay, I have to apply a transfer. It did not print what map function it has to apply, but it told me that it is a mapped RDD. Okay. So if I have to see what, so we said that it constructs a DAG. Can we see that DAG? Sure. For example, I can just call a debug string, and you can see what all transformations that it is supposed to apply.
So you just need to read it from the bottom up.
Right. So the parallel collection RDD is the one where you created a parallelized collection, and then you applied some filtering logic, and then you applied a custom mapping. You squared those. It is a mapped RDD. So this can be a complex RDD also. Let's say you can have, let's say, 10 more. You apply some map, some group by, and all those kind of fancy stuff, right? So this is what we meant when we said that it creates an RDD, a directed assigned graph operations, right? Right. So okay, that's good. But how do I get actual elements? How do I see the output itself? Right. So for that I will actually have to evaluate this DAG. And how will I do that? I will call some terminal actions. Those will actually ask Spark to evaluate the DAG, apply the ask transformations, and give me the result. For example, a few of them are like, let's say I want to do count of elements in the resultant RDD. So this is a terminal operation, and it will actually evaluate all the phases. For example, it actually did it was quite quick, so I couldn't show you the map phase and all, but you can still see it here.
We can probably see it in the right?
Right.
So it has basically two distinct transformations, right, that you can see on the web UI, right? So it wanted to do a, let me see the map.
Alright, you can see it here.
Application details. You need to go back to the application details. Setting applications. Application details.
Wait. It is just showing me the actions.
So if you expand it, you should be able to see it.
No, it is actually just showing me. I just asked for a
Can you
count.
scroll down it?
Yeah. No. But you know, right?
But
you saw the DAG, right? And you can even see it inside here. Okay, let's not get into the actual details. Since this partition is too small, let's say I was invoking this on let's say some data set which was stored in HDFS. I could actually see the job from resource manager that what is the current job, then it is actually mapping, it is actually filtering and what, right? But you understand what a tag is and what do we mean by when you say RDDs are lazily evaluated. Those are operations are just chain into a tag, and it won't be evaluated unless you call a terminal action. Yeah.
Is that we can stop for questions if you want. If anyone has any questions or questions.
Big version of JavaScript API, right?
No.
And you're just creating the streams, it's not computing and then computing
So-
it lazily in different.
I put it.
So one thing, these are not same or some different version of string. One gotcha with Java strings is those are consumed ones. Let's say I consume one string, I cannot then use that string once again. But RDDs can be consumed. Let's say so now we saw that actually we calculated the whole tag, right? That if those were string based, I would not be able to use RDD one again, which was this, right?
You can get rid of in between.
Right.
That's how I'll take one.
It was similar. See, so the API is kind of similar to Java or Java API, but the underlying architecture is quite
Yes,
similar to
and that's essentially the pitch, right? It gives you a very good programming model to actually think
the
about
black box and then you don't
Yes.
have to worry about all the
Underlying
scalability.
Yes.
Right.
So this is basically used when you are doing the programming, right? This is what
Yes, this is how we write code.
So I was thinking actually how is it different from Splunk analytics?
I
Okay.
don't know much about Splunk.
So I have used Splunk. By Splunk you mean the log analysis tool, right?
Yes.
So this is very primitive. What I am showing is very primitive. I am just showing word talk. But you can do pretty heavy stuff also. For example, you wanted to build an index so that it is searchable on, let's say, a log file, right? That's what Splunk does. You can aggregate based on those. So you get the hold of, if you get hold of, let's say, a distributed storage, the log file itself, you can apply a transformation and you can get what you want. But for Splunk, I don't know what they actually what it relies on, but you can build it using Spark also.
So it is more focused on log and
Right.
And this is a general purpose abstraction.
Right.
Like
typically the size when you have like unstructured data,
Mm.
right? Typically the size when you have unstructured data, right?
That's the good thing about Spark, right? It's not confined to unstructured data. It will easily talk to an already existing Oracle database or a Postgres database that you have. It's fine with that. It's fine with Cassandra as well.
There are relevant connectors.
Yes.
Yes.
It's not there for everything yet. But anything that talks JDBC, that's fine with Spark, right?
Work with ordered data, for example, I mean, where order of the data matters. Say, for example, the code does matter.
So yeah, you can do that. So you can,
aggregations and all those operations.
yeah, you can do
I think
that.
you have programmatic control to take care of that if it doesn't do that for you. Right?
You can add your own operations.
Yes. Yeah, we have.
We'll show it towards the end. That's going to sort of demo the power of Scala per se to add more operations to the already existing, but we'll demo that.
This seems like Apache Solr, where it is doing the transformation of data and
Yeah,
something more variable.
I guess since this example is pretty trivial, what I am showing, but I can show you some non-trivial examples also where you can see actually the difference where it
Can
shines.
we handle unstructured data?
Yeah.
So basically, let me answer the unstructured part, right? So when you have unstructured data, so what Spark will do is it will infer a schema for you. Spark has the ability to infer a schema for you, and then it gives you that schema. Now once you have that schema, it becomes like a statically typed thing, right? And then you have your full collection-based operations on that. So it gives you the ability to specify a schema as well for unstructured data, or what you can do is let it infer and infer that for you. That's good at both things.
You were telling that you have a predefined function, right? So you are using all the things in order to write too much of code in hand. Right now I am seeing that all are predefined. Suppose I want to do something different to Spark.
A collection operation which isn't supported by Spark. We'll demo
So
that.
you will demo it.
We'll demo it.
Right.
Yes.
So it is more similar to like an map reducing.
So see, it provides you with map and reduce as well. plus the ability to do a lot of things that you would inherently write complicated MapReduce jobs for, right? So it has better abstractions